in Killian fissure, you know, an sp2 carbon becoming sp3, only this carbon, a new chiral carbon is developed here, and only around this carbon, you know, it's going to differ. The rest of the structure will always remain same. So in every step of Killian fissure, you're going to get a pair of diastereomers. You're going to get a pair of diastereomers where the configuration only around one carbon atom will be differing. And now, you know, we know diastereomers which differ in configuration only over one carbon atom will be called epimers. Conventionally, the aldehyde is going to be the principal functional group. So every time we go about naming them, maybe for the sake of writing the IUPAC nomenclature or giving them a chemical name, every time I go about naming them and in the process numbering the number of carbon atoms, it has to start upside down. Yes or no? Yes or no? Because CHO is the principal functional group, you know, when I go about numbering the chain, I'll start from the aldehyde end. And yet again, because you know that the chain is always going to increase upwards, the chain is always going to build upwards, I'll have orientation differing, I'll have configuration differing, always at the second carbon atom, yes or no? And in the process, I'll be getting epimers around the second carbon atom, and you know, let me know them as C2 epimers then. C2 would mean differing at carbon 2. Now take it as a rule for the time being. You will certainly understand and relate it better. For the time being, I mean, the rule would be Killian fissure would produce a set of C2 epimers. Killian fissure will produce a set of C2 epimers. Alright, Killian fissure will produce a set of C2 epimers, and a pair of epimers, C2 epimers on rough degradation. A pair of C2 epimers on rough degradation would give you the same sugar. I repeat, a smaller sugar on Killian fissure is going to give you a pair of C2 epimers, and only those two C2 epimers on rough degradation would give you the same sugar. Fine. C2 epimers on rough degradation would give you the same sugar. Another way of stating the same is, if you are getting the same sugar from two different sugars on rough degradation, they are C2 epimers of each other. Fine. And then, you know, very quickly let's go into the application of this. Because we learnt about these methods of increasing or decreasing the number of carbon atoms. These names based upon people, you know, who figured it out. Killian, this guy Ruff, the German scientists, they found this method of, you know, increasing the number of carbon atoms or decreasing the number of carbon atoms. So based upon people who dealt with it, who discovered it, and let's quickly put it in practice. Let's apply this to increase the number of carbon atoms and travel this journey from simple carbohydrates to relevant carbohydrates. All right. So we have seen how we have been able to convert a triose to a tetrose. So we might want to begin with tetroses. So many facts about stereochemistry would be learned in this topic. It gives you an opportunity to know more about stereoisomerism. So I recommend, you know, while we are moving down this family tree of sugars, let's be very attentive. Please ask me any doubt which you have, but we are going to keep it simple. You know, we are going to increase the number of carbon atoms one by one in individual steps of Killian fissure. So let's begin with these epimers, the tetroses which we had. Let's recall, let's understand. We started with this form of glyceraldehyde. We started with this form of glyceraldehyde. All of them, the fissure projection which I have drawn, in all of them, the fissure projection which I have drawn will have CHO on top, CH2OH on bottom. Certainly we are aware about the basic rules of drawing fissure projections. The horizontal lines, the horizontal lines are coming out of the plane of the board. The horizontal lines will be coming out of the plane of the board. The vertical lines will be going into the plane of the board. So starting with this form of glyceraldehyde, a step of Killiani fissure, and I got a pair of aldotetroses. I got this pair of aldotetroses, where I kept this OH undisturbed, and then above it there was an OH to the right and to the left. Fair enough? Maybe for lack of space or necessity, I'm always going to focus about, or for the time being we are going to focus only about the orientation of the OH and the hydrogen atoms. So all the spaces blank here would mean hydrogen atoms. In all these structures, on the top there is going to be CHO, at the bottom there is going to be CH2OH. Now this, and step of Killiani fissure, would produce a pair of pentoses, aldopentoses. So see what I am doing. This time, while converting this tetrose to a pentose, I understand that it's going to be different at this carbon atom, the newly bound carbon atom, the newly coiled carbon atom. So I'll have to retain the chirality of these two carbon atoms. I'll have to retain the configuration of these two carbon atoms. So in both these structures, I have these two OH on right. In both these structures, I have these two OH on right. Fine. And only over this newly bound chiral carbon, I'll have an OH to the right or to the left. And this is where I told you, we're always going to get a pair of, yet again because I got a number at top to bottom, we're always going to end up with a pair of C2 epimers. We'll get a pair of C2 epimers. Yes or no? Now an aldotetrose of this kind will give me a pair of aldopentoses of this kind. Certainly the other epimer is going to produce two other types of aldopentoses. Yet again, while drawing these two aldopentoses, I remember that I'm going to keep these two unchanged. I'm going to keep these two unchanged. Only over this newly bound chiral carbon atom, I'll have an OH to the right or the OH to the left. Fine. So I guess you have been following me throughout. You understand what I am doing? In every step of Killiani fissure, for the lower carbon atoms, I am retaining the chirality, I am retaining the configuration. Only over the new bound carbon atom, I am having an OH to the right or to the left, realizing that only over this carbon atom, there is going to be a difference in configuration, and each step of Killiani fissure is going to produce a set of C2 epimers. It's going to produce a set of C2 epimers. And if you have followed me all right, I'll want you to perform this last step of your own. I guess you figured out you're going to need a fresh page for this. You're going to do it in the fresh page, and starting from these four aldopentoses, how many hexoses do you get? How many aldohexoses do you get? 8. So if you have been following me throughout, draw the 8 aldohexoses. Let me know if you have a doubt anywhere. And I just want you to take note of one fact. Although I've been keeping it simple, retaining the previous configurations, altering it only at the newly bound carbon atom. If you notice, still I've retained a pattern. That pattern is over the new chiral carbon atom, I've always written OH on right first, then left. Right first, then left. Even here, for these two epimers, I had the OH on right and then left. So very deliberately, I've been observing an order that's retaining the previous configurations, and over the new chiral carbon atoms, I've been drawing the OH on right first, then left. This is what I expect you to follow, and give me the structure of the 8 aldohexoses. This should not take long. do it of your own.